Welcome to our lesson on some applications of matrices. Now, we've already talked about the area of a triangle and whether points are collinear in a previous lesson. So today's lesson is just going to focus on how to decode a message using decode and actually code a message using matrices. Now, I've kind of gone through the process here with this first example. I'm going to go through an overview of the process and then talk a little bit more about how you would set this up if you were going to do it on your own. So the first thing you need to have is, a key, so to speak, where we have what each letter stands for. So we all have to agree that 1 means A, 2 means B, 3 means C, and so on. We use 0 to denote a space. So we have to have that kind of agreed on ahead of time. But once we have that agreement, we can take a message such as Happy Thursday, and we can write it in a matrix, in a 5x3 matrix. Now I'll explain why I chose a 5x3 matrix in a few minutes. But I write that code, that message, in a 5x3 matrix, and that's what you see here. So we have this matrix that spells out Happy Thursday. Now what I'm going to do is I'm going to turn that into letters. Turn that from letters into numbers. So I take the same matrix, but this time instead of having the letters, I go to my alphabet key. And I recognize that H is actually the number 8. So I change H to 8. I recognize that A is the number 1. So I change A to 1, and so on. And I do that for the entire message. When I'm finished, I have the second matrix that you see here. So this one is just taking my letters and turning them into numbers. That's all. Now, once I've had that step finished, so that's what I would do if I'm going to send a message. I would first take my message, turn it into letters, and then I'm going to go ahead and use some kind of what we call an encoding matrix. So this encoding matrix, K, is going to be what we use to actually change the numbers within our message matrix. So what's important here is, and this is why I chose a 5x3 matrix, I would actually have chosen my encoding matrix first. Once again, both people on either end of this message, the one creating it and the one receiving it, have to agree on an encoding matrix. So we have decided that our encoding matrix is going to be a 3x3 matrix. And we know that part of our process, and you'll see this in a second, is that we're going to multiply this by our message matrix. Well, the order, and you're going to see this below here, that we're going to actually multiply will be the message matrix times the coding matrix. So we have to have kind of understood ahead of time that since our coding matrix is a 3x3 matrix, our message matrix must have 3 columns. Okay, it can have as many rows as you want, but it has to have 3 columns. So that's why I chose at the beginning to create a 5x3 matrix. I'm just creating a matrix that's 3 columns and as many rows as I need to fit the actual message. So then the process is, so let's just kind of recap here. I've started out by creating my message, turning that message into numbers, and then I'm going to take whatever my coding matrix is that we have established ahead of time, and I'm going to multiply my message matrix times my coding matrix. Okay, so let's go ahead and do that. Obviously, I'm going to have you do this with the calculator because if you're going to be sending messages, you're going to be using technology to help you code or decode. So go ahead and take a second, type this either into your Desmos calculator or into your graphing calculator and figure out what the new matrix will be. So when you multiply those 2 matrices together, you're going to get this final matrix. Now, this is what your message looks like when it has been coded. So now if someone picked this up and intercepted it between you and the person you're sending it to, they wouldn't be able to read your message because look at your numbers. They in no way correspond to the letters of our alphabet. So somebody picking this up is just going to see a string of numbers that doesn't make any sense. But here's the thing. Because we're sending this message, we don't necessarily want to give anyone that might intercept it any kind of hidden clues as to how to decode the message. So I do not want to send it in a matrix form because that at least tells the person that found it that my coding matrix was a 3x3 matrix. I don't want them to know that. because there's 3 columns, they can figure that out. So what I'm going to do is I'm going to remove the brackets and make it just a string of numbers. So this string of numbers is going to look like if I took my matrix and just wrote it like this: 23, negative 31, negative 45, negative 9, and so on. So we could just write this random string of numbers, and then if we have this on paper or in an email, and somebody intercepts it, they're not going to be able to make any kind of sense of it. Okay, so it doesn't make any, there's no direct correlation between these numbers and my alphabet. So that would be how we could take a message and change it to code it so that we can send it as a secret message. Now let's go the opposite direction. So now let's say I was given this message. Okay, I want to decode it. So now I have to work backwards. I have to take that message, and I know that my decoder, my decoding matrix, is going to be a 3x3 matrix, right? So I know that I'm going to have to take my numbers here and change them into a matrix that has 3 columns. So you're going to see that down here, 3, negative 26, 21. That's my 3rd column. I start a new row, and so on. So this is my coded matrix. This is the message that I would receive. What I have to do is then undo the multiplication of K, my coded my kind of coder matrix. And that's going to be the inverse of K. Because remember, we've talked about we can't divide matrices, but we can multiply by the inverse, and it has sort of the same effect. So I'm going to have to multiply by whatever my coding matrix was, but the inverse of it. Now, we could figure out what that is here. I'm not that concerned with that because we're going to let technology do the work for us. So I'm going to multiply by my original coding matrix, but because I'm decoding, I need to do the inverse of that. So once again, this is something where I can ahead of time, I know what my coding matrix is on both ends. So I've received this message. I'm going to multiply by the inverse of what we've already decided that our coding matrix is going to be. And that's going to give me a matrix that I can then use to decode a message. So go ahead and take a moment and multiply those 2 matrices together. So when you've done this, again, using technology, I'm not doing this by hand. There's no sense in doing that with a matrix this size, or with matrices this size. I get this matrix that I can now actually decode. So go ahead and use the agreed upon number to letter correspondence and take a second and try to decode this message. So you could do this. I might start out by writing the letters in a string of, or the numbers in a string of numbers so that I know kind of where the words go together. So then my 0 denotes a space. Then I would have 13, 5, and then another 0 to denote the space, and then 13, 15, 14, 4, 1, and 25. So take a moment and decode this message and then come back and check. So you get this message that says, meet me Monday. So now whoever received that could have decoded it based on what you gave them. So here's the thing. You can create any message you want, but you have to make sure that you have agreed upon the coding matrix on both ends. So whoever you're going to send it to, you have to make sure they already have that coding matrix. Because if they don't, and you try to send it in the same message, obviously anyone that picks that up that understands how to break the code could do so. Just so you can kind of see other ways of encrypting messages that have been used throughout time. One of the oldest known ones was the Caesar shift cipher, and it's literally just taking the alphabet and shifting it. So shifting it to the right 3 units results in D being written by the letter A. If you mean to write E, you actually write the letter B. So it just gives you a way to shift the alphabet to create a new message. This one would not be terribly difficult to crack, for obvious reasons. There's a limited number of ways that you could shift the alphabet. You could get creative if you wanted to, but there's really very limited number of ways you can end up actually shifting the alphabet. Another way is hiding messages in plain sight, and I thought this one was interesting. There was a, I think, Greek a Greek man named, I'm not even going to try and say his name, Hystatius, maybe? Hystaius? I don't know. Sent his message to one of his like people that he commanded, and he would shave the head of his most trusted servant, marking the message on his scalp, and then the servant would just let his hair grow out again. So that's a way you could send a message in plain sight. So don't go shaving your friend's head to send a secret message, but that's just a way that obviously you could send a secret message. You can send, I don't know if you've ever watched like, you know, some of those crime drama shows. Sometimes you'll see like somebody sends a message within a painting. So, you know, it's not obvious that it's there, but if you look closely, the pixels have messages within, or pictures. A picture file can hide other documents or other files as well. So that's, you know, that's used now on kind of a more, you know, intricate scale. The Pigpen cipher, I thought this one was quite interesting. You create the alphabet in some kind of an arrangement, and you make sure that each letter has a different look to it. So for instance, the letter H looks like it's enclosed on 3 sides, but the bottom is open. So if you wanted to send the letter H, you would just send that symbol. The letter E is enclosed completely by a square shape, and we would just send the square shape to denote the letter E. You can be creative with these as well. So Y looks like, you know, part of an open triangle with a dot at the interior of that angle. So there's, you know, an interesting cipher called the Pigpen cipher that can be used to send messages as well. And then more recently, this is kind of the standard, and I kind of wanted to point this one out because if you look at it, these look like matrices, right? So this is taking part of a message or a string of data, part of that string of data, and adding to it something else. Now, this matrix that they're adding to it is made up of both letters and numbers, and we get something completely different. This is then what is used to encrypt that particular piece of data, right? So it is matrices that we're using here. Might not be using matrix multiplication, but we're definitely using some form of a matrix here. And this is kind of what we're using in some form today. So just a quick little, you know, history of coding messages and what that has looked like and how it has transformed over the years. Okay. If you're interested in any of these things and you want to learn more about some of these previous types of ciphering, please let me know, and I can give you a couple links that you could explore a little bit. All right, we'll talk more about this in class. We'll even practice a little bit with decoding and encoding messages, and I will see you then. Have a great day.